This is lesson 6.4, page 380, solve compound inequalities. A compound inequality consists of two separate inequalities joined by and or. Now, I underlined and or because those two words you're going to see over and over again in this video. And versus or are telling you two different things with inequalities. The graph of a compound inequality with and is the intersection of the graphs of the inequalities. So, if you're like, what is that telling us? Look below at what they write. Let's take the inequality x greater than negative 2. You can see the graph of it here. They have an open circle at negative 2 and anything larger than that. Look at x less than equal 1. It'd be a closed circle at 1 and shading left of that. Now, if I want negative x greater than negative 2 and x less than equal to 1, if I want that compound inequality graphed, what I'm going to do is I'm only going to shade where these two overlap. So notice what they put for the answer. You know, x greater than negative 2 would be an open circle at negative 2 shading right, and x less than equal 1 would be a closed circle at 1 shading left. You notice the answer and means we're only going to shade where these two are in common, where they overlap. These two graphs only overlap, and maybe I should highlight it here with a different color pen. You notice these two graphs only overlap from negative 2 up to positive 1. That's my answer to this. And is where you take your two inequalities and only shade where they overlap, what's in common. That's and. Let's talk about the other type of graph when we have a compound inequality with the word or. The graph of a compound inequality with or is the union of the graphs. In other words, we're just combining them both together. So look at this example. Let's say I wanted to combine the graph of x greater than equals 0 or x less than negative 1. Now, x greater than equals 0 would be this picture up here that I'm pointing at here. X less than negative 1 would be this picture that I'm pointing at. Now, or is combining those together. So you'd have this combined graph that I'm circling in blue. It'd be x greater than 0 combined with x less than x less than negative 1. You're just combining both the graphs together. So and is where the graphs overlap, or is just combining both the graphs together. So we got to know the difference between and or. Let's try a few. This first one, I want all the real numbers that are less than negative 1 or greater than equal 4. So x less than negative 1 would be this statement. X greater than equal 4 would be this statement, and you notice they want or. Combine them together. Well, let's graph that. Let's combine those together. Well, x less than negative 1 would be this. X greater than equal 4 would be that. There would be the picture of that. Okay? X less than negative 1 or x greater than equal 4 would be this graph picture. I'm combining the two graphs together. Let's try this next one. All real numbers that are greater than or equal to negative 3 and less than 5. Well, x greater than equal negative 3 would be this. And x less than 5 would be this. So and means I want to only draw where these two overlap. So let's go to the next page. We're going to look at the number lines. I only want the overlap for these two. So x greater than negative 3 or equal to negative 3. That would be starting at negative 3, and you can see an arrow here. I'm shading right. X less than 5 would be starting at 5 and shading left, and so where these combine together right here. Okay, where I'm highlighting or where I'm shading right now, these are the numbers. Like 0 would be greater than negative 3 and less than 5 at the same time. So that would be a picture of this graph. I'm only shading where they combine, where both graphs combine together. We'll be asked to do this with real-world problems, like here. A crane sits on top of a car and faces toward the front. The crane's maximum and minimum heights above the ground are showed. I highlight them. Max is 18, minimum is 5. They want me to write and graph a compound inequality for this. So the lowest the thing can be is 4 feet. The highest is 18. So the crane will always be 4 feet and higher, and it will never be more than 18 feet. This is an and problem, so I'm only combining the two graphs together where they overlap. So this is an overlapping situation, and. So here would be the inequality. The height of the crane would be greater than equal 4 and less than equal 18 at the same time. And you can see my picture here, h greater than 4 would be shading everything to the right, but h less than equal 18 would be shading everything to the left. I'm only going to shade where the two combine together. Maybe I can kind of color this in a little bit better. So that's only from here to there, and that's it. That's my graph for this problem. When you solve a compound inequality, the number is a solution of the compound inequality with and if the number is a solution of both. So in other words, when you see the word and, for a number to be a solution, it has to satisfy both inequalities. For example, when I go back a couple screens, like here, 1 would be a solution to both of these. 1 is greater than -3, and it's less than 5. So to solve an and statement, the number must make both statements true. It's got to make both true. Okay, went too far. Next, a number is a solution of a compound inequality with or if the number is a solution of at least one of the inequalities. So, I've talked about this in class before. It'd be like your mom saying, if you want to go to the game tonight, you must clean your room or do the dishes. That word or is very important. It doesn't mean you have to do both. It means you got to at least do one of the two. So that's what's going on here. If the number solves at least one of the inequalities for an or problem, then it would be a solution. Okay, let's talk about solving a compound inequality with and. Okay, now, one thing, this is not in the textbook. There's no such terminology as this. This is just something that I guess when I was a kid I kind of made up in my head. When you have an and problem, you can write your inequalities in this form. Now, there's no such word as this, but I always thought of this as a triple inequality. And here's why I'm going to say triple inequality. Can you see how there's one? Let me underline them here in red. There's 1, 2, 3 parts to it. Can you see that? You can only write ands as triple inequality. So if you see a triple inequality, it's automatically an and problem. So when I look at this problem, I already know it's and because it's a triple inequality. I can only write triple inequalities that are in and form, okay? So and triple inequalities go together. So I want to solve this. Now the book shows this. I'm going to show you something a little different. The book shows you this in a minute, but I think this is easier to do and less work when you have a triple inequality, okay? We're going to treat this like our balance scale. Okay, I got to solve for x. X plus 5, you can see I have my onion drawn. Now, obviously, to get rid of plus 5, you have to subtract. Now, you have to subtract from all 3 parts. Remember, this is a triple inequality. Can you see how I subtracted 5 from the left side, how I subtracted 5 in the middle, and how I subtracted 5 on the right? I can solve my triple inequality in that way. So 2 minus 5 is -3. The 5's in the middle cancel. 9 minus 5 is 4. So the answer to this compound inequality would be -3 less than x less than 4, which you can see. This is automatically an and problem because it's a triple inequality. So let's graph it. Here's my open circle at -3. Here's my open circle at 4, and remember, on an AND problem, I got to draw the overlap. It's only what do they have in common. So here are the numbers bigger than -3. Those would be going right. The numbers smaller than 4 would be going left. Does it make sense that I'm only shading what's in between? There's my AND answer, okay? Let's try one here. -7 less than x minus 5 less than 4. Now, do you notice this is a triple inequality? This problem is definitely an AND problem, number 4. Let's solve. So I got to get rid of -5. So I drew my onion. I'll add 5 to the middle. I'll add 5 to the left. And I'll add 5 to the right. And when I do that, I'll get -2 less than x less than 9. Okay? They want me to graph it. So AND means I'm combining these graphs together. So I want the values that are greater than -2 but less than 9 at the same time. And there's a picture of that. Here are the values bigger than -2 but less than 9 at the same time. Let's do another one. This next one. 10 less than equal 2y plus 4 less than equal 24. Now, do you notice? This is automatically an AND problem. It's a triple inequality. I can only write triple inequalities that are in AND form. So, onion, let's take away the 4 from each part of the triple inequality, which would give me 6 less than equal 2y less than equal 20. Divide everything by 2 to get the y in the middle by itself. I'm trying to get that y by itself. I got to divide by 2. And that would leave me 3 less than equal y less than equal 10. Okay, so let's go ahead and graph that one. 3 less than equal y less than equal 10. You notice I put a closed circle at 3 and a closed circle at 10. And since this is AND, remember it's an AND problem, I'm combining what they have in common. So greater than 3 is to the right, less than 10 is to the left. It's only where they overlap, which would be here. Okay. Now, if you have an OR question, remember the AND problems you can write as a triple inequality, the ORs you can't. So do you notice in the statement, can you see how they had to write these inequalities separate? They had to use the word OR because the only inequalities that can be ANDs are triple inequalities. So they had to just do these separate. So we just got to solve each separately. So 2x plus 3 less than 9. You can see they're taking away 3 from each side and then dividing by 2. There's one inequality, x less than 3. And then the second inequality, they had to add 6 to each side and then divide by 3. You get x greater than 6. Okay, now it's an OR problem. That means just combine both graphs together. So you can see that. I'm going to circle it in blue right down here. You can see they drew x less than 3 to here on the bottom left, x greater than 6, open circle, 6 shading right. There's the picture. Now, when you do, I'm going to do a couple of these real quick. You notice, before I do any of these, number 7 has to be an AND problem because it's a triple inequality. Number 8 has to be an AND problem. It's a triple inequality. You notice number 9 is definitely an OR, so is 10. You cannot write OR problems as triple inequalities. So let's quickly solve 7. So there's my triple inequality. If I add 8 to the middle, left, and right, I'd get -6 less than x less than 7. And then I can graph that. So -6 less than x less than 7. I got a key point at -6. I got a key point at 7. I want the numbers bigger than -6 and the numbers less than 7, and I'm combining those graphs together. There's the combination of the graphs. Any of the numbers that you see shaded would make this a true statement. Let's do one OR problem. Number 9, this is an OR. I got to solve these separately. So there's the first inequality. I'll take away 1. I'll divide by 3. So h is less than -2. Here's the second inequality. 2h minus 5 greater than 7. I'll add the 5. I'll divide by the 2. H is greater than 6. So I have to graph h less than -2, or, remember, or h greater than 6. Let's do that. Okay, so h less than negative 2 would be open circle negative 2, and then we have h greater than 6, open circle 6. We're shading left of negative 2 and right of negative 6. There's the graph for h less than negative 2 or h greater than 6. They will have you do some story problems for this. Here's a problem. I'm not going to read it, but they want us to write a compound inequality that describes the possible temperatures in Fahrenheit. So I'll let you read that on your own, but you can see down here, write an inequality that will do that, and you can see that down here, and you might remember this. There's that Fahrenheit formula we learned, or at least were exposed to in lesson, I think, 5 of chapter 1. You can see they wrote a compound inequality. This must be an and problem then. And then you can see that they are isolating F to get their temperature range for this. So we will have to write our own inequalities and then solve the inequality, graph our solutions, and then they'd ask you, like, maybe identify 3 possible temperatures. When you look at the graph, if this is my solution set, I could say 0 degrees, negative 50, and negative 100 would be solutions because those are all in the solution set. I'm going to stop the video here. If you have questions, make sure you ask in class.